Now let's move on to the next section. We have multiplication and division in standard form. So when it comes to multiplying and dividing in standard form, it is best to multiply or divide the numbers and the 10 to the power of n term separately. So for example, for multiplication, we would do, so if the numbers are usually in this form. So if we had two numbers that are in standard form and we had to multiply them, the best thing to do is multiply the numbers by themselves, the numbers that is not attached to the 10 by themselves, and we multiply the numbers associated with the 10, with the base 10 by themselves. Okay, so when we multiply indices with the same base, we just add the powers. So similarly for division, if we have two numbers that are in standard form and we need to divide them, just put one on top of the other and we just do the numbers separately and the powers that are associated with 10 separately as well. But when it comes to division or dividing in standard form, we deduct the powers associated with the base number, which will be 10. Okay, so let's look at some examples. So we have example 1.4.07. Work out the value of 2 times 10 to the power of 6 multiplied by 8 times 10 to the power of 5. Express your answer in standard form. So notice for this question, we are multiplying. So as we're multiplying, what we need to do is we need to multiply the numbers first and then the indices. So we can rewrite them as 2 times 8, so just the numbers, 2 times 8, and we can write just the powers by themselves, which is 10 to the power of 6 times 10 to the power of 5. So 8 times 2 is equal to 16, and 10 to the power of 6 times 10 to the power of 5 is 11, because we just leave the 10 as it is, and we just plus the powers, okay, because we're multiplying. Now from here, notice that is not our final answer because the answer is not in standard form. The reason is the number 16 is more than 10. So what we need to do is convert the 16 to standard form. So we need to move the decimal place 1 point to the left. So if we move the decimal point 1 point to the left, so in order to get back to the original 16, we need to move the decimal point to the right, 1 place to the right. So 1.6 times 10 to the power of 1 is the same thing as 16. So instead of writing 16, we could substitute it in for this. So we could rewriting the whole answer as 1.6 times 10 to the power of 1 times 10 to the power of 11. So our final answer is going to be 1.6. And here notice that the base is the same. We are multiplying, so we just add the powers. So 11 plus 1 is equal to 12. So 1.6 times 10 to the power of 12 is our final answer. Okay, let's look at another example. Work out the value of 12 times 10 to the power of 3 divided by 24 times 10 to the power of minus 6. Express your answer in standard form. So this question requires us to divide the numbers first, then the indices. So remember, when we divide the indices, we basically indices when we divide the indices with the same base, sorry, I should say, then what we do is we just deduct the powers. Okay, so let's do each term at a time. So we do 12 divided by 24 is equal to 0.5. And we have 10 to the power of 3 divided by 10 to the power of minus 6. Now, as we have the same base, which is 10, the power we just deduct as we're dividing. So we do 3 minus 6, where we get 10 to the power of 9, because minus and a minus becomes a plus. So 6 plus 3 is equal to 9. So our answer is, we can write it as 0.5 times 10 to the power of 9. But notice that this is not in standard form, as the first number is less than 1. So what we need to do is we need to convert the 0.5 into standard form. So in order to get it to standard form, we need to move the decimal point 1 place to the right. So if you move the decimal point 1 place to the right, we get 5 times 10 to the power of minus 1, right? Because in order to get this 5 back to 0.5, we need to move the decimal place 1 point to the left. Hence, we have 10 to the power of minus 1. So instead of writing 0.5, as both of these are equivalent, the left-hand side and the right-hand side of the equal sign, it's the same thing. So we just replace the 0.5 with 5 times 10 to the power of minus 1. And we already have a 10 multiplied by 10 to the power of 10 to the power of 9 already there. So we just add the powers because we just need one lot of 10. No, we don't need two lots of 10. So we have 5 times 10 to the power of 8 because we have minus 1 plus 9. Okay? Now it's your turn. Have a go at these exercise questions and see how you get on. Okay, so we've seen multiplication and division involving standard form. Now let's look at addition and subtraction in standard form. So when adding and subtracting in standard form, it is a good idea to make sure that the powers of the indices are the same. So for addition, the general rule will be if you have two standard two numbers expressed in standard form, what we do when we're adding them, we just add the powers, add the numbers in front. But we can only do that if the base, so the base number here, is the same. Okay, if both of them are the same, notice it 10 to the power of x, 10 to the power of x. As long as they are the same, then we can do this. If they are different, we cannot do this. Okay, so we carry out addition. The base numbers are identical and the powers are identical to each other. So we only add the numbers, not the powers. Okay. So similarly for subtraction, we can take we can subtract the numbers in the front, okay, a and b separately, as long as the base numbers are the same. Okay. So when we carry out subtraction, so we only deduct the numbers, not the powers. Okay. So in this case, it's only the numbers that we're deducting or adding or deducting, not the powers. Okay. So let's look at an example. So we have calculate 3.8 times 10 to the power of 4 plus 2.2 times 10 to the power of 3. Without using a calculator, give your answer in standard form. So notice that we have an addition operator here, but the power of the bases, so a base number, the power of the base numbers are not the same. We have 10 to the power of 4 here, and we have 10 to the power of 3 here. So what we must do is we must make them the same. So we start by rewriting one of the numbers in such a way that both powers of 10 are equal. So the left-hand side number, so the left-hand side number, if we move the decimal place 1 point to the right, then we know that it will reduce the power by 1, right? To get it back to the for it to be equivalent. Okay, so we have 38 times 10 to the power of 3, and here we now notice that the right hand side we just leave it as it is, but we have the same power here. We have a base with the same powers, so 10 to the power of 3 and 10 to the power of 3 here. As this is the case, what we can do, we can add the numbers in the front. So we do 38 plus 2.2, and we leave the 10 to the power of 3 as it is, times 10 to the power of 3. So we get 40.2 times 10 to the power of 3. But notice that this is not in standard form because 40 is a lot larger than 10. So we need to convert it back into standard form. So we move the decimal place 1 point to the left and we add a power here, which adds a power here, right? So we have 10 to the power of 4. Okay. Let's look at another example. We have calculate 1.25 times 10 to the power of 12 minus 9.81 times 10 to the power of 11. Without using a calculator, give your answer in standard form. So notice that we have a subtraction operator, but the powers of the base 10 are not the same. So we must make them the same. So we start by rewriting one of the numbers. You could choose either in such a way that both powers are equivalent. So we need to make them the same. We could choose either. So let's choose the right hand side here. So we have 9.81 times 10 to the power of 11. Now if we move this decimal place 1 place to the left, this number will increase by 1. Okay, so we have 0.981 times 10 to the power of 12. Now that both of these base numbers are the same, with the same index as well, we can just carry out the normal operation of subtraction, which is 1.25 minus 0.981 times 10 to the power of 12, which equals 0.269 times 10 to the power of 12. Now notice here, we're not done because this is not in standard form. This number is not between 1 and 10, so we need to move this 1 place to the right, this decimal point 1 place to the right. So if we move 1 place to the right, this power is going to reduce by 1. So we get 2.69 times 10 to the power of 11. Okay. Have a go at these questions. And it may seem a little confusing at first, but if you just follow the process, have a go at them step by step, and until you fully understand what's going on, until you're comfortable with them. Okay. And I shall see you in the next part of the lecture.